This is a video from section 1.1 in a linear algebra class, solving a linear system. 3 operations are used to simplify a linear system. Number 1, replace one equation by the sum of itself and the multiple of another equation. Number 2, interchange 2 equations. Number 3, multiply all the terms of an equation by a non-zero constant. Let's take a look at this example. Solve the following system of equations. So here are my equations. x1 plus x2 plus 2x3 equals 8. Negative x1 minus 2x2 plus 3x3 equals 1. 3x1 minus 7x2 plus 4x3 equals 10. So I label the first equation as equation 1, the second equation as equation 2, and the third equation as equation 3. Okay, so here's my strategy. I'm going to take equation 1 and add equation 2, and this arrow says basically to put the result back into equation 2. And when I do that, notice how this first term ends up going away. So I'm going to get a new equation 2 with no x1 term, basically. So this is what my new system looks like. So I get x1 plus x2 plus 2x3 equals 8. So notice that equation 1 remains unchanged. My new equation 2 becomes negative x2 plus 5x3 equals 9. And equation 3 becomes 3x1 minus 7x2 plus 4x3 equals 10. Okay, from here, I'm going to take negative 3 times equation 1. I'm going to add it to equation 3, and I'm going to put the result back into equation 3. And if you don't mind, at the same time, I'm going to take negative 1 times equation 2 and put the result back into equation 2. So I want you to notice something, okay? And I'm using equation 1 in both of these operations, right? Notice how this term, when I rewrite equation 3, I no longer have an x1 term. That's a good thing, okay? And also notice that the coefficient of x2 in equation 2 is going to turn into 1, okay? That's also a good thing. Now, watch what happens here. I get x1 plus x2 plus 2x3 equals 8. x2 minus 5x3 equals negative 9. And negative 10x2 minus 2x3 equals negative 14. Now, this is what I do next. I take 10 times equation 2, add it to equation 3, and put the result back into equation 3. And so notice when I rewrite equation 3, I no longer have an x2 term. So notice how this term is going to disappear, right? So there's no x2 term. When I rewrite this system, I get the following. I get x1 plus x2 plus 2x3 equals 8. So again, equation 1 remains unchanged. x2 minus 5x3 equals negative 9, and negative 52x3 equals negative 104. Okay, now I want you to notice something. The coefficient of x1 in the first equation is 1. It's exactly what I wanted. The coefficient of x2 in equation 2 is 1. That's also what I want. And when I perform this last operation here, the coefficient of x3 in equation 3 will also be a 1. And this is what I have. I have x1 plus x2 plus 2x3 equals 8. x2 minus 5x3 equals negative 9. And x3 equals 2. And notice how this system puts me in a perfect position to solve for x1, x2, and x3 immediately. So I want you to notice x3 equals 2, and I'm going to substitute 2 for x3 in equation 2 and solve for x2. So in other words, I'm going to replace x3 with 2 and then solve for x2. So I get x2 minus 5 times 2 equals negative 9. And so, therefore, x2 equals 1. And then I'm going to replace x2 with 1 and x3 with 2 in equation 1 and solve for x1. So this is called back substitution. So x1 plus 1 plus 2 times 2 equals 8. And when I solve, I get x1 equals 3. So the solution here is the ordered triple, if you will, 3, 1, 2. And that's how you do this example. Let's take a look at another example. So let's take a look at this system here. Suppose I had 2x1 plus 2x2 plus 2x3 equals 0. And then negative 2x1 plus 5x2 plus 2x3 equals 1. And 8x1 plus x2 plus 4x3 equals negative 1. Okay. So my ultimate goal, there's a couple goals, right? I want the coefficient of x1 in equation 1 to be a 1. Okay, let's start there. So I'm going to take 1/2 times equation 1 and put the result back into equation 1. So let's just do that one first. And so when I rewrite my system, I get x1 plus x2 plus x3 equals 0. I get negative 2x1 plus 5x2 plus 2x3 equals 1. And then I get 8x1 plus x2 plus 4x3 equals negative 1. Okay? Now, from here, I'm going to take 2 times equation 1, add it to equation 2, put the result back into equation 2. And I'm going to take negative 8 times equation 1 plus equation 3, put the result back into equation 3. So notice how I'm using equation 1, and there's a real strategy here. I'm using equation 1 to get rid of the first term, x. Let me say it this way. I'm using equation 1 to get rid of the x1 terms in both equations 2 and 3. That's really what's happening, right? Now, my first equation doesn't change. My first equation should say x1 plus x2 plus x3 equals 0. Now, in the second equation, notice I'm going to take 2x2 and I'm going to add 5x2 to get 7x2. And I'm going to take 2x3 and add 2x3 to get 4x3. So it's 7x2 plus 4x3 equals 1. So remember, my second equation no longer has an x1 term, and that's a good thing. Now, let's take a look at here. I'm going to take negative 8x2 plus x2 to get negative 7x2. And then I'm going to take negative 8x3 plus 4x3 to get negative 4x3. And then I get negative 1 on the other side. Okay? So over here, I get negative 7x2 minus 4x3 equal negative 1. So this one's interesting, right? Because I want you to notice something. If I take negative 1 times equation 3, and I'm going to put that result back into equation 3, I want you to notice how equations 2 and 3 end up being exactly the same. Okay? So notice, we get x1 plus x2 plus x3 equals 0. We get 7x2 plus 4x3 equal 1, and 7x2 plus 4x3 equals 1, right? Now, from here, right, I'm going to take, essentially, I'm going to take negative 1 times equation 2, and I'm going to add equation 3. And I'm going to put the result back into equation 3. And that basically will vanish equation 3, right? Does that make sense? And then also, I'm going to take 1/7. We'll do that on the next one. I changed my mind. We'll do that on the next one. Let's keep it this way first. So what we end up getting is x1 plus x2 plus x3 equals 0. And then 7x2 plus 4x3 equals 1, right? And notice how equation 3 basically disappears. Now, from here, I'm going to take 1/7 equation 2, and I'm going to put the result back into equation 2. When I do that, I get x1 plus x2 plus x3 equals 0. And I'm going to get x2 plus 4/7 x3 equals 1/7. Okay. Now, let's talk about this. Notice how we have two equations. We have two equations. How many unknowns do we have? We have 3 unknowns. And what that tells me is that I have one free variable. Now you might ask, which one's the free variable? Now, the free variable I claim is going to be x3. Okay? So here's how this works. I'm going to let x3 equal t. Now, I can solve for x2 in terms of t. So x2 is negative 4/7 t plus 1 over 7. Okay? Now, remember, x1 plus x2 plus x3 equals 0. So I get x1 plus, and then it's negative 4/7 t plus 1/7. And then I'm going to add t, because that's what x3 is, and set that equal to 0. So notice I'm expressing x1, x2, and x3 in terms of t. So x1 plus 3/7 t plus 1/7, right, equals 0. So x1 is negative 3/7 t minus 1/7. And so remember, t can be any real number. So my solution, x1, x2, x3, is going to look like the following. Now, x1 is negative 3/7 t minus 1/7. x2 is negative 4/7 t plus 1/7. x3 will be t. And remember, t is any real number that I want. T could be 5, t could be 10, t could be anything. And that's how we solve a system like this. All right, so this is a video from section 1.1, and we did 2 examples of solving linear systems. Okay, thank you.